Hello and welcome to 7 Days of Science, where I can't be here in the studio this week in person because of a very special bit of coverage coming up later on in the episode. Starting off the news this week, the BepiColombo mission has sent its first pictures of Mercury back to Earth. This little probe was launched all the way back in October of 2018 and has been on a steady journey of our solar system for the last couple of years, coming past Earth back in April last year and passing by Venus twice, once in October last year and another time much more recently in August this year. Now, finally, it has completed the first in what will be 6 flybys of Mercury, with the plan being that the probe will eventually be in a position to be pulled into orbit at the end of 2025. This time, BepiColombo reached an altitude above Mercury of about 199 kilometers. That's just under double the height of Earth's atmosphere, although of course Mercury is a lot smaller than Earth, only being slightly larger than our own moon. Unfortunately though, the images we received were not quite as low as the probe got, and instead it was only best positioned to take images of Mercury at around 1,000 kilometers. While these images are really cool and very exciting, BepiColombo is only really going to be able to get on with its mission in 2026, when it's all set up and in orbit. And now, we move over to Ben, with some really exciting...
Thanks, Doug. So there's been some absolutely incredible news this last week that I'm sure many of you will already have heard about, but in case you haven't, we're here to change that. A paper has just been published that describes not just one, but 2 new species of Spinosaurs, specifically baryonychine Spinosaurs, from the Wessex Formation of the Wealden supergroup of southern England. This is very exciting news for many reasons, and as such we've decided to make a special feature episode of 7 Days of Science to cover this news as fully as it deserves. So, what are these new dinosaurs? Well, one of them is named Ceratosuchops inferodios, meaning hell heron horned crocodile face, and the other is Riparovenator milnerae, meaning the riverbank hunter named in honour of Milner. Dr. Angela Milner was one of the paleontologists who originally named baryonyx, and sadly, whilst work was being done on these new Spinosaurs, she passed away. So the authors thought it would be fitting to name a new baryonychine after her, a really nice tribute to a brilliant paleontologist. Both of these Spinosaurs are, as I've mentioned, baryonychines, meaning they're more closely related to the European baryonyx than to Spinosaurus. Interestingly, as we'll investigate further in a bit, Ceratosuchops and Riparovenator were also found to form a new grouping with the African Suchomimus, called Ceratosuchopsini, but baryonyx was not included in this group. The material that these Spinosaurs are based on is pretty interesting, being found between the years of 2013 and 2017, with brain cases and snout tips known for both animals, enabling direct comparisons of their anatomy. In addition, quite a few tail vertebrae were referred to Riparovenator as well, finally providing us with more information on the baryonychine tail, which turns out to have been quite deep and compressed from side to side, with taller neural spines than we previously thought. Though clearly it's not quite as paddle-like in its appearance as what was recently discovered for Spinosaurus itself. Both these animals also have roughened bony regions around their orbits, which in Ceratosuchops also ends in a large boss just behind the eye, that likely would have had a horny covering in life. As I've briefly mentioned, these Spinosaurs originate from the Wessex Formation that outcrops on the Isle of Wight just off the southern coast of England, a part of the larger Wealden supergroup that also includes the formation in which the baryonyx holotype was discovered. Indeed, isolated teeth from the Isle of Wight have long been considered to have come from baryonyx, and with the naming of 2 new species, it would appear that 3 different Spinosaurs were coexisting in the early Cretaceous Barremian stage of England. This is undoubtedly very exciting news, and I was actually lucky enough to go and see the fossils of these new dinosaurs for myself the day after the paper was published, as I happened to be on the Isle of Wight for fieldwork. Right, so here I am on location in the Dinosaur Isle Museum on the Isle of Wight. On the back there, we've got Riparovenator, and right here, Ceratosuchops. Some very nice material from the new baryonychines in the Wessex Formation. It's just incredible. It was absolutely incredible to see these fossils in person after reading about them and being so excited about such a remarkable discovery. And since this is such a special discovery, we reached out to paleontologist Dr. Darren Nash, one of the authors of this paper and creator of the excellent blog Tetrapod Zoology, to ask him some questions about these new Spinosaurs.
Thank you, Ben. Well, I've travelled all the way over here to the University of Southampton to find out what I can about this paper.
So I'm here now interviewing Dr. Darren Nation, one of the authors of this paper. Doug should be here any second. I'm pretty sure he knew it was an online meeting. Anyway, thank you very much, Dr. Nash, for being here with me and being willing to answer some questions about these new baryonychines.
Thanks for having me.
So first question I have is, what are some of the main features that distinguish Ceratosuchops and Riparovenator from each other and from other baryonychines?
That's a horrible question. Most of our initial assumption on being confronted with these two new specimens is that they probably were baryonyx. The fact that they're from a different sedimentary basin, the idea was could they possibly be different species from Baryonyx walkeri from Surrey? But once we started actually looking in detail at the best preserved bits of both of these new dinosaurs, the brain cases and the snout tips, there were various detailed differences both from each other. Both specimens differ from one another, and they also differ from Baryonyx walkeri. And these features are small anatomical differences. They're to do with things like the shape of the specific structures, like on the brain case, back of the brain case, and the specific anatomy of the shape of the snout tip. But they make our two new animals more similar to the African baryonychine, Suchomimus, than they are like Baryonyx. That was backed up in our phylogenetic analysis. Both of these new specimens group closer to Suchomimus than they do with Baryonyx, and the details that make them more like Suchomimus, or at least like a brain case that's from Niger and is said to be Suchomimus, the differences make them distinct from Baryonyx and distinct from each other, and they exceed the sort of differences that you expect to see in a single theropod species or genus. So we ended up with no option but to name both as new species. And as I've said in my writings on these two new animals, this wasn't our initial assumption, they're two new species. We went back and forth on all the different possibilities, and kind of almost reluctantly came to the conclusion that they have to be different from Baryonyx walkeri, and they have to be different species from each other. And that's the situation that we've ended up with, two new species.
Thank you. So why is the material we actually have for these animals particularly significant?
Dinosaur remains are quite well known from the Wessex Formation of the Isle of Wight, this famous section of rock, part of the Wealden supergroup that's yielded loads of dinosaurs. But actually finding dinosaurs that consist of good skull material is pretty rare, and it's especially rare to find two similar dinosaurs, both consisting of skull material in relatively close proximity, both in time and location. So finding these two new dinosaurs, both represented by good skull material, was wow, that's really like hitting the jackpot. One of the specimens obviously consists of a partial skull together with an articulated partial tail, so we've got every reason to think that there's actually at least part of an entire skeleton that was actually preserved, and probably has been mostly destroyed through erosion. But there's indications, I can't say right now what those indications are, but there's basically indications that there's more material there that we either hope to discover in future or will be describing. It's basically like it's really cool to find two new dinosaurs, both represented by good skull material.
So I imagine there must have been a lot of discussion about whether to name these as new taxa. Was there ever a point in the description of these specimens when you considered leaving them unnamed, or considered that they might represent different growth stages of the same animal?
Yeah, part of our process in considering what we do with these animals was, are they just growth stages of the same one species, or are they growth stages of Baryonyx walkeri? And so how would you actually demonstrate that? You would need to find indications that they're of different ages. And, what a key thing here is that both of these new animals are about the same size. They're about the same stage in maturity in terms of like what's been fused up in the skeleton. And both of them are also about the same size and about the same stage of maturity as the holotype of Baryonyx walkeri. So if these animals are growth stages of the same thing, then we'd want them to be different sizes, and we would want evidence that they come from different stages in growth. And that's not the case. That's contradicted by what I just said. So the evidence is against that. And then there's the phylogenetic stuff, the fact that when they're coded, when we code all their anatomical features, the fact that they don't group together with Baryonyx walkeri, they group with the African animal Suchomimus, is also not consistent with them being growth stages. How we actually interpret the taxonomy, what decisions we make on which animals we recognize as different genera, is somewhat arbitrary, and there's different interpretations of how we should deal with this. So it's been suggested a couple of times in the past that Suchomimus from Niger should be treated as a species of Baryonyx. And if you go with that, if you're happy with that, and that's a totally, fine interpretation, then these animals should be identified as as different taxa within Baryonyx walkeri. But we opted to go with the consensus at the moment, which is that Baryonyx and Suchomimus are identified as separate genera. So do we have our new animals as species of Suchomimus? Well, again, they're as different from Suchomimus as they are from, in the number of diagnostic characters, as they are from Baryonyx. So that didn't seem to be like a good solution. And when it comes to the actual features that we're talking about, the features that make them diagnostic, I've kind of avoided talking about them so far because they're all really tedious things. But when I say tedious, they're really detailed. And to explain them, you have to first of all explain which aspects of anatomy I'm talking about. So, for example, if you look at the back of the brain case, there are structures called the basisphenoids, and the shape of these basisphenoids and their facets on the bottom, they are different, and the exact hollows and the position of the shallow sulci that are on the back of the basisphenoids, those are different in these two animals. The form of these bones called the exoccipitals and how they contribute to the occipital condyle, the ball on the back of the skull, that's different in these two animals than it is from Baryonyx. And there's a list of other features like that. They are important anatomically, but they're quite difficult to understand. We don't have enough of these animals to say one of them has got like a tall big crest like along the length of its snout and another one doesn't. The differences aren't that obvious, but they are distinct enough. The differences are big enough for you to say that these should be identified as different taxa. And like I say, based on the results we found so far, the best working solution at the moment is two different taxa that are on the Suchomimus branch and are not on the Baryonyx branch, which is a surprise. We didn't expect that result.
Yeah, it was quite a surprise reading that. It's very interesting. Okay, so some people might consider it unlikely that three species of similar, closely related large carnivorous dinosaurs were potentially coexisting in the Wealden at this time, but is this actually a particularly unusual situation?
What we think about Mesozoic faunas at the moment is that it appears to have been the norm for there to be 2, 3, or even more similar sized large theropods, sometimes even very closely related theropods, living in the same environment. So today, you expect there to be, you might expect there to be like one big predator in an environment, but even in modern assemblages, that's not true. You think of like places where there are no modern predators like giant theropods, but even in things like big cats, you have 2 or 3 species or more living in the same environment doing different things. You look in the dinosaur faunas, you name an assemblage, a specific like fauna or ecosystem that's got a big theropod in it, and it will generally have more than one. The latest Cretaceous of Western North America, I think it's well known that's very unusual for whatever reason. Tyrannosaurus rex is, so far as we know, the only big predator in those ecosystems. That's odd, but elsewhere throughout the Jurassic and certainly the first approximate half of the Cretaceous, it's typical for you to have 2 or 3 species, sometimes similar species, living in the same place. So finding 2 more in the Wessex Formation when there's already Neovenator and an unnamed mid-sized tetaneurin and Eotyrannus, which is a mid-sized tetaneurin, is not unusual relative to other Mesozoic ecosystems.
So what is the significance of these baryonychines being discovered in Europe in terms of the geographic origins of Spinosaurs?
Because Spinosaurids are known obviously from Africa, they're in South America, there's fragments from Australia, there's Southern Asian taxa, and there's European ones as well. Working out the biogeography of the group is kind of complicated, and people have come up with different ideas. There's probably 2 main ideas. One is that they were widely distributed across the continents prior to continental fragmentation that occurred in the mostly in the Jurassic. So they had like a Pangean distribution, which would mean their history going back to the sort of first half of the Jurassic, and then their distribution later on is due to Pangean fragmentation. Another idea is that they're mostly Gondwanan, they're mostly of the southern continents, and then on 1 or 2 occasions specific lineages moved south into Europe or Asia. So those are the 2 most popular ideas. But in recent years, the number of Spinosaurids that have been reported from Europe has increased, not just these 2 new Wessex Formation Isle of Wight animals, but also fragmentary remains from Spain in particular, which are from Spinosaurines, the same group of Spinosaurids as Spinosaurus. So if Spinosaurines are in Europe, in addition to South America and Africa and probably elsewhere, and there's more baryonychines in Europe than there are anywhere else. Elsewhere they're obviously in Africa. When you map this distribution onto the cladogram, then you find overwhelmingly there's like a strong European signal. Most of the lineages within the group, their early members are in Europe, and their younger members are in South America, Africa, Asia, ostensibly Australia as well, based on this one cervical vertebra. So overall, the picture there is that this is probably ancestrally a European group that's got several different dispersal events to the other continents. So we use that as like that's quite a big deal. That's obviously something we focused on in the paper. And the big caveat here, and the thing again, I've said this in writings on this paper, the caveat is that we know almost nothing about the Jurassic history of Spinosaurids. There's an unpublished specimen from I think Mali, and there's some possible teeth from Eastern Africa, which might be from Spinosaurids, but otherwise there's nothing Jurassic at all. And if Spinosaurids are close relatives of Megalosaurids originated probably in the first half of the Jurassic. So Spinosaurids must have a history that goes deep into the Jurassic, and yet we've got no knowledge really of what's going on there. So whatever conclusions we make at the moment are, as is always the case in science, they are provisional, and we wouldn't be surprised if they get totally overturned, if we find something else, and fingers crossed that we do in the future. Who knows?
Yeah, we need to get out there and find some Jurassic Spinosaurs. Perhaps that's what Doug's up to right now. I have no idea where he could be.
Spinosaurids, of course, are really remarkable because they're so anatomically modified relative to most other tetaneuran theropods. All the animals all the taxa that we know about have got these very long crocodile-like faces. So it's a classic example of a group where we really, really want to know what the sort of like air quotes intermediate stages were like as they became modified from presumably a megalosaurid-like condition to the advanced Spinosaurid condition. So you kind of, we really hope that we'll discover some sort of like Archaeopteryx of Spinosaurids, some like intermediate condition. And at the moment, there is no such thing. And when such an animal is found, assuming that it is, that will be huge news. I mean, such a discovery would be a great day in the world of dinosaur research.
Yeah, definitely. Hopefully that happens soon. Yeah, so talking of future research, it's been mentioned that this paper is not the only work being done on these new Spinosaurs. So what sort of things can we expect from future studies, and what do you hope to investigate further about these two taxa in particular?
Yeah, both animals are very well preserved, by which I mean, not meaning in terms of completeness, because obviously they're fragmentary, but in terms of like how well preserved the bones are. They're beautiful, they're immaculate, they're very conducive to scanning. So we have had them CT scans. We've got fully rendered, digital models of them, which means you can do things like study the nerve pathways and what the brain cavity was like, all that kind of stuff. So there's already this work that's been done on working out the nerve distribution and so on in Spinosaurus. It would be really handy and really interesting to do the same sort of thing for another group of Spinosaurids, for Baryonychians. So that's one thing that we could do. We do plan to reconstruct what the brain anatomy was like in both taxa, and see what that tells us about the sensory abilities and nerve size and so on in Baryonychians. So there's a whole line of work to do with soft tissue anatomy and neuroanatomy. There's a fuller, larger description that needs to be done, as always with an initial paper. Our first paper is the initial, basically the reporting of here's the material and here's how we've interpreted it, here's the names that we've given these two new specimens. But in terms of a full detailed description, which will include a lot more material than we've included in the initial report, that needs to be done. Baryonyx walkeri itself was monographed in 1997, which, if you're my age, is not long ago, but in terms of years is actually ancient history in terms of dinosaurs. So Baryonyx walkeri needs to be re-monographed with new photography and sort of more detailed, more in-depth study. So that's on the cards as well. That'll be done at the same time as this. And as nearly always happens in my experience, once you start finding out about new animals from a specific location, you'll discover that there's actually these other things that are sort of found nearby, not necessarily in the same sediments, but I can't say anything that will give the game away, but basically there are more Wealden Spinosaurids to come. So there's quite, as someone who's been involved in research on Wealden dinosaurs for a couple of decades, there's quite a few as yet undescribed Wealden theropods that will be described or named in the future. So there's still more stuff to come, even from a place as well explored and well known as southern England. So there's a bunch of work that's going to come out soon.
Yeah, Well, that's very exciting. Yeah, so thank you so much for taking the time to do this interview, and make sure to follow Darren on Twitter @Tetsu, and of course, make sure to go and read the Tetrapod Zoology blog, which will be linked below, especially the one about these discoveries. So thank you very much.
Thank you for having me. Good to talk to you. Take it easy.
So, a truly remarkable paper that has so many fascinating implications for these ancient ecosystems, and for the origins of one of the most unique and enigmatic dinosaur groupings. And now for some very quick other paleontology news that also needs to be mentioned. First, the naming and description of a new chasmosaurian ceratopsid from the Upper Cretaceous of New Mexico, Sierraceratops turneri. Sierraceratops is notable for its relatively quite short but robust and naturally compressed brow horns, as well as a variety of other anatomical features that distinguish this as a new taxon. This new dinosaur supports the idea that the North American landmass Laramidia was home to a great deal of ceratopsian endemism, with several other related species also known from this region. And also worth quickly mentioning is yet another newly named dinosaur, this time a troodontid from the Upper Cretaceous of Inner Mongolia, Papiliovenator nemenguensis. Known from an almost complete skull and parts of the body, this dinosaur was notably short-snouted for a troodontid, and was found to be placed at an early diverging branch on a group including all other late Cretaceous troodontids. So what a week it's been for dinosaur discoveries. Let's just hope we get some more like this in the future. And thanks again to Dr. Darren Nash for taking the time to talk to me. Make sure you go and check out Tetrapod Zoology if you haven't already, and be sure to follow him on Twitter too. Back to Doug in the studio.